is whatever you like. Turn this party into a club. I'm talking drink, dance, smoke, break, party all night. Come big girl, what's up? Don't you want me like I want you, baby?
Hello everyone, I'm Wonder Maker. Everyone loves watching sparks fly, right? Want to try it out for yourself? But here's the catch, sparks flying everywhere. Are you scared? Even if sparks don't scare you, you wouldn't want your new clothes to instantly become a holy outfit, right? So today I'm bringing in some high-tech, a gesture-controlled remote tool for forging sparks. It's safe, super cool, and the experience is off the charts. Before we get started, let's explain how these beautiful iron flowers come to be. The star of the show appears, steel wool. Normally, this stuff is as cheap as cabbage, just $1. But come New Year, the prices skyrocket. Steel wool, its name tells you it's made of steel. But here's the question, can iron burn? Hold on, the answer is coming soon. The answer is yes. And it burns brilliantly. Steel wool is thin and fluffy, offering a huge surface area relative to its volume, ensuring excellent contact with oxygen. Plus, it's lightweight and has a low heat capacity. So just a little heat can quickly raise its temperature. Once the temperature rises, the iron start romancing the oxygen in the air, forming iron oxide while releasing a ton of heat, resulting in a dazzling shower of sparks. A truly lively spectacle. Up close, you'll see the sparks dancing in the air, like little fairies. If you wave the steel wool around to expose it to more oxygen, the oxidation reaction intensifies, and the sparks instantly transform into magnificent rings, almost like magic. Those flying sparks are actually droplets of molten iron. Because they're so tiny, they cool and darken rapidly as they fly, eventually forming little iron beads that fall to the ground. So, as long as you choose the right location and maintain a safe distance, forging sparks can actually be quite safe. Of course, provided you steer clear of flammable or explosive materials. Alright, enough talk, let's get right to it. The actions for forging sparks are actually very simple. Spinning, swinging your arms up and down, and left and right. We're using two 10kg servos and one gear reduction motor to perform these three motions. A 1000 RPM geared motor is sufficient. If it spins too fast, the steel wool will be done in seconds. And you wouldn't want the fun to end in just a few seconds, right? There are pan-tilt servo accessory kits available online. Just assemble them together. In the software, set the servo rotation angles 180 degrees on the x-axis and 90 degrees on the y-axis. With the mechanical part sorted, let's talk about how to detect hand gestures. We'll be using an MPU 6050 module here, a 6-axis attitude sensor. With it, we can determine the current motion orientation of the device. When you hold the remote, the sensor's position relative to your palm is fixed. By reading the angular velocity on the y-axis, you can gauge the angle of your up and down swings. Reading the x-axis gives you the left and right swing angle. Simply put, with just a wave, the device knows what you're doing. But how do we detect a spin? Hold on, let's take it step by step. A spinning motion can be broken down into individual movements, from one position to the next. By using the acceleration data on the x and z axes, we can obtain the vector angle of each movement. By continuously calculating and summing these vector angles, you'll find that a full spin adds up to exactly 360 degrees. After detecting a spin, you can also time it to determine the speed, allowing you to adjust the motor's rotation speed accordingly. Furthermore, the sign of the angle indicates whether it's spinning clockwise or counterclockwise. Don't forget to include the code for the swinging motion. The core part is complete. Now it's time for modeling and assembly. 3D print a cross-shaped wheel and a motor housing. Grab 2 circuit boards from JLC PCB. They are a gem in the industry, no doubt about it. Start soldering the components. The gesture-controlled unit is finished. There's a power signal indicator on the back and a charging port on the side. Press the big button to start gesture detection. The small button is for settings. Now, let's install the pan tilt servo. Attach a coupling to the rotating plate. Apply fireproof tape to the 3D printed parts, safety first. It's almost complete. Time to take it out for a test. Remember to test it in an area free of flammable materials and have water on hand. For the mounting, I chose a camera tripod. Avoid cheap stands, I've tried them, and they tip over. It matches the camera tripod's quick release design perfectly. Convenient and practical, truly a lazy person's dream. Let's test the remote control's performance. Clockwise rotation. Quick spin to speed up. Slow reverse rotation. Fast reverse rotation. Swing it. That's pretty much it. Swings over 90 degrees seem unnecessary. We'll test it with ignition later tonight. Clamp on the steel wool and get ready for ignition. Not enough power. We'll need to make some adjustments. I'm planning to go all out. Directly swapping in a drill motor. Since I don't have a power battery on hand, I'll just use 2 lithium batteries. It gives off the vibe of a huge electric fan. Let's test the effect again. Beautiful. Doesn't it look like Doctor Strange's portal? The little, weak me is huddled here, shivering. The rotation speed is too high, and the burn time is a bit short. Let's take it outdoors to see how it performs. My camera lens got blasted. Hit that follow button to show some support. If this video gets over 100,000 views, I'll further refine the details and then open source the project.